Welcome all to the Modern Remote and Wireless Test Setup and Considerations web seminar. Today, we will hear a presentation by Neil Forcier, who is an applications engineer in Agilent Technologies based out of the Agilent, Colorado, United States office. Currently at Agilent, his areas of focus include remote instrument control, timing measurements, and advanced power applications. In addition, we will also have online myself, Sri Vengadaraman, the Market Development Manager for Europe, based in Paris from Agilent, France, and Marlo Manalotto, Business Development Manager from Agilent, New Jersey, to help answer your questions you may have during the webcast. Just a quick word on logistics before we start the web seminar. For everyone's comfort, this is a lecture-style meeting. However, you can send questions in writing at any time during the session through the Q&A or question and answer functionality of the WebEx meeting. We will do our best to answer your questions during the session, but may come back to you after the session if we haven't been able to. Importantly, while the answer to your question may be published for others to see, we will keep your identity private. Please be reminded this webcast will be recorded, so you can review and share with your colleagues at any time. So that's the end of the introductions. Now, Neil Forcier, I will pass on to you. Thank you.
All right, Sri, thank you. And once again, my name is Neil Forcier. Welcome to Modern Remote and Wireless Test Setup and Considerations. And today in our global society, we are more connected than ever. We can wirelessly access data, information. We can wirelessly share data and information with each other from almost anywhere at any time. There's three main technologies or infrastructure that this global connectivity is built on. And the three main ones are the cellular or mobile network that can be found across the globe in any developed country, as well as the Ethernet or wired LAN network backbone that can be found, once again, across any developed country that makes the backbone for the internet and that we can find in any type of office building, always has an Ethernet infrastructure. And then finally, Wi-Fi. There's a whole plethora of low-cost, off-the-shelf, what I'll call Wi-Fi edge devices that we can connect to the edge of a cellular or a LAN network that allow us to access that network wirelessly. Now, in this presentation, I'm going to be talking about using these three technologies and these low-cost Wi-Fi edge devices to basically give us ubiquitous or anytime access to test data, to remote control of test instrument control. And the focus here will be on LXI instruments, remotely accessing and remotely controlling wirelessly LXI instruments, because LXI have LAN connection capabilities. Some of what I say can be applied to USB I/O type devices, depending if you had some type of converter. But once again, the focus will be on LXI or LAN instruments. So here's the agenda for the presentation. In the first section, I'm just going to talk about real briefly what LXI is and the basic, sort of the common ways the LXI remote control of instrumentation is used, or how we remotely control LXI instruments. In the second section, I'll talk about going wireless with LXI. How can we create simple wireless test setups in the office or on our bench? How can we make all of our instruments wireless? How can we have a wireless test system? I'll talk about that in the second section. In the third section, I'll talk about going the distance with wireless LXI. So the idea is no longer are we controlling instruments that are nearby in the lab or in the office or at our workbench. How can we control remotely and wirelessly LXI instruments that might be outside our office monitoring a solar panel, or kilometers away in an industrial plant making a measurement, or even across the globe? How could we access an instrument, control it, and get data from it wirelessly? In the fourth section, I'll talk about some of the firewall or network security hurdles. when you're accessing instruments through a land or cellular network, there can be some network hurdles. What can we do to get around them in a secure way? And then in the second to last section, I'll talk about how we can use smart devices and the power of the cloud to control our instruments and retrieve data from anywhere at any time. And then finally, I'll conclude and take any questions. So yeah, as you can see, there's a number of sections to go through in the span of about 45 minutes. So some of the concepts I won't get into too deep, but there'll be links throughout the presentation where you could get more information on some of these topics that I talk about. And also at the end of the presentation, there'll be a list of places you can go to get more information. So let me get started with the first section. LXI, for anybody who's not familiar with LXI, it's an instrument I/O or an instrument connection standard, just like GPIB. It stands for Land Extensions for Instrumentations. And so LXI is based off of land I/O or land connectivity. But besides just having an instrument with land connectivity, LXI also defines that an instrument will have certain software drivers built in, such as IVI. The instrument will also have a web interface, meaning I could access the instrument, its network settings, and in some cases, control the instrument via a web browser as long as I'm connected to it from a LAN connection. So LXI is not a Agilent-specific standard. It's shared by multiple test and measurement vendors. And today, I believe there's about 1,600 LXI instruments out there. For more information, though, on LXI, you can go to the consortium's webpage, which is shown on this slide. Okay, so now let me go over just sort of the basic or how people today are mainly connecting to LXI instruments remotely. So the simplest, easiest way to connect to an LXI instrument is to simply use a LAN cable, connect one side of the LAN cable to your computer or your controller, and connect the other end of the LAN cable to the instrument. I then can access the instrument via web browser, via a driver such as Visa, using custom software, or custom software via LAN sockets. If I wanted to control multiple instruments, I would simply use a LAN switch or a LAN router, connect the instruments to the LAN switch or the LAN router, and also connect the controller or computer to the LAN switch or LAN router, and now I can control multiple instruments. And that's typically how a all LXI test system is set up. Another way you could do it is if your company allows it. Some companies do, some companies don't, but if you could put your instruments on the company network, you could actually access them from anywhere inside your company's network, which is typically referred to as an intranet. So as long as your computer's on that same intranet and that the instruments are, you could access them through the computer. So those are the three main ways that typically LXI instruments are remotely controlled today. And just to lay a little bit of the foundation for what we'll be talking about later is, if my computer can access my LXI instrument, as long as it's on the same local network. And the local network might be just the instrument connected to the computer. It might be the instrument connected to the computer via switch or router. It might be the instrument on the same local intranet. Now, my controller, let's use an internet analogy. My computer, when I'm accessing a web page, let's say google.com, my controller computer acts like a client. It acts like a client because it's initiating the conversation with the web service. So in network talk, we call that a client. Now, the Google.com or the Google web page or the Google server is acting like a server, meaning it accepts the connection, you do a transaction with it, it then closes that transaction after you've exchanged your data. Now, in our model, where we're controlling instruments with a computer, the instrument is acting as the server. The instrument is sitting there, the computer initiates the conversation, and then the instrument responds, some commands are exchanged, and once again, the computer then closes the connection and it's done. Now, once again, it's easy to access any of the internet web pages or servers, I'll say, from your computer or from your smart device or from your tablet PC at home, at the cafe, or in your office. Where things get difficult, and one of the network hurdles that we'll talk about later, is the fact that your instrument is acting like a server inside your company's network, and your company's network, to protect from attacks, it assumes that everything inside of its network is a client. So it's going to block all incoming connection requests, which typically makes it hard for you to access instruments inside the company firewall. But once again, the client, the server model, and the idea that most company firewalls and even your router at home will block incoming requests, and we'll talk about that in this presentation, how to deal with that. Okay, so we got through the first section. Once again, just a quick overview of what LXI is, how we generically or commonly connect to instruments using LXI. And so in this section, we're going to talk about creating a wireless test setup using LXI instruments. So in this slide, I just sort of state some of the advantages and disadvantages of using wireless versus having wired I/O. And I think a lot of these are already self-explanatory. So here we'll progress into going more and more wireless, but here's an easy sort of way to create a pseudo wireless test setup. So the idea is, most of us at home have a Wi-Fi router where we connect our internet connection to, and our computers at home or whatever that have Wi-Fi capabilities can then access that router and the network that router is connected to wirelessly. We can do something similar with our instruments. We can wire our instruments to the Wi-Fi router. We set up a network name. We use our computer or our controller to connect to that router's signal, and now we can access our instruments wirelessly. Of course, the instruments are still wired, but we can move the controller around as we will. Now, typically, in your company, you could set this up, but once again, it would have to be a private network, meaning the router is not connected to any other company network. It's just its own network. Your computer connects to it. Typically, most companies or IT departments will not allow you to connect the router also to the company's network, simply because that creates an access point into the company's network, where if someone was in the parking lot of the office, they could get that Wi-Fi signal, and if they could get on that router's network, it acts as an access point into the company's network. So once again, typically all right to operate this type of wireless test setup as long as the router is independent of the company's network. But once again, this setup is just what I'll call pseudo wireless because our instruments are still wired to it. Here we kind of break our instruments free by using what is known as a Wi-Fi bridge. So the idea is what a Wi-Fi bridge does is it basically will convert the Ethernet protocol that the instruments are running off of to a Wi-Fi protocol. So here we would take the Ethernet bridge, we would configure it. You basically would run it with maybe a CD or a web page, and you would tell it what the name of the Wi-Fi network is, what the password is, so the bridge can automatically connect to that. So now we have our Wi-Fi router sitting in the middle. Our controller can access it wirelessly, that network, which allows it to access the instruments wirelessly. And this is great for setting up, a distributive test type setup in the office where you have instruments maybe spread around the large DUT, and you want to configure them and reconfigure them. You don't have to worry about the I/O cables. Or if you wanted to make all your instruments at your bench, wirelessly, so you could access them remotely wirelessly. One drawback, though, to this type of setup is the fact that the Ethernet bridges have to be plugged into AC power. So there is one way we can sort of overcome that Typically, today, most Wi-Fi, because Wi-Fi technology is so prevalent and so low cost, most Wi-Fi devices have multiple capabilities. So you typically don't see a single product that sells as a Wi-Fi bridge, let's say. Typically, when you buy a Wi-Fi router, it'll actually have the capability to act like a bridge or to act like a Wi-Fi repeater or to act like a router. Also, today, there's a recent surge of what I'll call pocket routers. So a pocket router is, once again, a router, but it also can act as a repeater, can also act as a Wi-Fi bridge that simply is very small, pocket size, the size of a small mobile phone. And the idea is it has one Ethernet wired connect port, and it can broadcast a Wi-Fi signal. Now, one great thing about these pocket routers, besides their small compact size, is that they often can run off of AC line power as well as USB power. So the idea is you could use a piece of Velcro it to the instrument, use the instrument, if the instrument has a USB memory port, you could use the USB memory port to power the router and then wire the Ethernet connection to the pocket router. Now, if I'm just working with a single instrument, I would configure the pocket router as a router, give it a network name, and I could use my computer to wirelessly access that network and also the instrument that's connected to it. Now, let's say I want to control 5 different instruments wirelessly using pocket routers. Well, what I could do is I could configure one of the routers to act as the router or to broadcast the Wi-Fi network. I could then configure the other 4 that are connected to my other 4 instruments to act as Wi-Fi bridges and to connect to that main router's network. So in that case, once again, if the instruments have USB connectivity and LAN, I could power the routers from the instrument and access all the instruments wirelessly. So now I don't have the overhead of a power line cable for the router. So once again, great way to set up a wireless test bench or for doing local distributed tests where you're moving instruments around a large DUT. Okay, so here we just looked at going wireless but sort of in the local sense. How could we control our instruments at our lab bench, in our office, or maybe 50 yards from our desk in an environmental chamber? We looked at how we can do that wirelessly. In this next section, we're going to be looking at ways we can control instruments that might be outside of our office, 100 meters or 100 kilometers. How can we control those instruments remotely and wirelessly? So once again, in this section, I've sort of already stated we want to control instruments outside of the office. This will be great for remote control of instruments, maybe in an industrial area that's far away, or a power station, or for doing long-distance distributed tests where, for instance, let's say you have a high-speed rail line and you want to monitor vibration on the rail line at different points that are kilometers apart. How can we do that with a single PC wirelessly? How can we set a test like that up when there's no Ethernet infrastructure that's readily available for us to plug into? Well, I'm going to talk about basically 3 methods in this section. The first one is sort of what I'll say the simplest, but the least flexible, and that's by using a Wi-Fi repeater. So with a Wi-Fi repeater, all we're doing is we're taking a Wi-Fi signal or Wi-Fi network, we're rebroadcasting it, so basically extending its range. So let's say you're testing a solar panel that's 100 meters outside of your office. You could set up a Wi-Fi router in your office and then use a repeater to transmit that signal so it reaches outside your office. You then could use an instrument with a Wi-Fi bridge that's outside monitoring the solar panel to basically access that instrument remotely. for doing data logging or anything like that. And the idea is you no longer have to have a controller out there with the instrument, and you no longer have to make frequent trips out to where the instrument is to retrieve data or to set up the instrument, so on and so forth. Now, repeaters come in low-cost consumer versions that you can buy. Also, as shown in the pictures, there are also industrial strength or repeaters. And so with an industrial quality repeater, you could actually extend the Wi-Fi network up to 1 mile. And you can see also in the picture, you can get ones for outdoors that can be kept powered by solar power. But of course, remember, when you extend the Wi-Fi network, you're extending it sort of in a circular transmit pattern, meaning it's transmitting in every direction. So it's sort of a waste of power if you're just trying to reach a single point. Also, too, if the network's not well protected, you're basically extending the network for 1 mile, which gives people around your office ability to possibly get into that network if it's not well password protected. Okay, going the distance with wireless, method 2, using a long-distance RF Ethernet bridge. So you heard me talk a little bit about Wi-Fi bridges. RF Ethernet bridges are the same thing, where you're taking an Ethernet signal and you're converting it to a different communication protocol. So a RF bridge, instead of converting it to a Wi-Fi signal, it converts it to a 9 megahertz ISM band signal for longer range transmission. So the idea here is you'll have at least 2 bridge devices. You'll have one that connects to the access point of the network, which means it could be connecting to your company's network, or it could be connecting to a Wi-Fi router, or it could be directly connected to your computer, and it's once again serving on the client side. Then, and that's simply referred to typically as the access point. That's why it's labeled AP in this figure. And then also there's what's known as the slave unit, where it connects to the instrument, once again Ethernet cable, and it is told information on what access point it is going to connect to, and it'll connect to that access point. These devices have a built-in encryption protocol, so they're really secure. They can easily transmit up to I'm using miles in the slide, but up to multiple kilometers away. 15 miles is typically their limit, and that's with a specialized antenna. And once again, their range depends a lot on the topology, your surrounding topology, how much interference, how much of the ISM band is being used in your area, sort of determines their maximum range. But they can easily do, up to 3, 4, 5 kilometers. Now, these are also a great solution for distributive test, because a single access point can typically support up to 16 slave units. So you could have 16 instruments, multiple kilometers apart, and be controlling them with one single PC without having to make trips out to those instruments, without having to have PC stationed with those instruments. You could access all those instruments wirelessly. One more note, though, too, is depending on the interference in that area will affect the latency. And these type of devices will typically have at least a second of latency for doing a transaction between the controller and the instrument. Okay, and the third method, and probably the most flexible method, is using cellular routers. So a cellular router works just like the router you have at home, except it doesn't access the internet via a wired Ethernet connection. It accesses the internet via a mobile or cellular network. So the idea here is to use a cellular router, you need typically a USB broadband device from whoever your local carrier is in your area. which is going to be typically a monthly plan where you'll pay for a certain data rate over the month. That USB broadband device connects to the cellular router and gives the cellular router its connection. So assuming that you're in range of a cellular network, you could essentially control an instrument across the globe, or even control an instrument in a moving vehicle, because the cellular network can handle handing off from tower to tower at high speeds. Now, there is some considerations to note when using a cellular router. The first, once again, is you have to get a mobile broadband device and a cellular plan to establish a data plan. The second is the router's IP address will typically change on a daily basis. And once again, this depends on your carrier and your area that you're using. This is highly undesirable, though, because if you were accessing an instrument, miles or kilometers away, and the IP address changes, all of a sudden you're going to lose connection with that instrument. So one thing I had to do when I was doing this testing was I had to establish a static IP address with my cellular carrier. Now, for me, that costed a little bit more extra money, a one-time fee. For some carriers, it may be free, it may not be. Also, with a cellular router, the router typically is going to use a built-in firewall, because the router thinks that anything connected to it is a client. And like we discussed earlier, that's not necessarily the case. Instruments act as servers. So I'm initiating a conversation from outside the router with the instrument that's on the router. And the router by default will block that. To change that, you would have to go into the router settings and change the router settings and use either what's known as port forwarding or DMZ to tell the router to allow traffic to go to that instrument. And I'm going to be talking about that a little more in the security section, is sort of poking holes in the router's firewall so you can access an instrument. But once again, method 3, cellular routers, probably the most cost associated with this method, but once again, the most flexibility, because you can access an instrument from kilometers away, from across the ocean, anytime, any place. Finally, to conclude this section, I just wanted to mention, if you're doing testing in remote areas or rural areas where there's not an Ethernet network connection, there often won't be power connection. And so I just wanted to point out, there's two types of main ways if you didn't have AC line power, to generate AC line power, and that's with generators or a battery system with inverters. Now, for testing purposes, the battery system with an inverter is typically the ideal way to go. And so the idea is you have these huge batteries, they're being converted to AC with an inverter and being output to the instrument. Now, the batteries can last for a couple days, and the batteries of the inverter can often be recharged with solar, with wind power, with a generator, or if they were around AC line power, AC line power. So once again, there's also options out there to power the device if you're in a remote area where there's not a network connection. And the great thing too about these is you can often turn the device on, turn the device off using the same remote access that you might be setting up with the instrument. So you might be able to actually control this inverter battery system using the cellular router that you're using to access the instrument, let's say. Okay, now moving on to section 4, getting around firewalls and network security. Okay, so when trying to access an LXI instrument over long distance, there's two main firewalls you run into. The first is the personal router. Let's say wherever you have the instrument, or let's say you have an instrument at home, or let's say you have an instrument somewhere and you're using a router, whether it be a cellular router or a Wi-Fi router, if your computer is outside of that router's local network, meaning it's not connected to the router via a wired LAN cable or that router's Wi-Fi network, the router by default will block you because it assumes that everything on its network is a client, and once again, instruments are servers. And the same is true with our company's network. Let's say, so far in this presentation, I've been talking from the perspective of we're sitting in our office and the instrument is outside of our office. But what if we're traveling, we're doing business traveling, and we're outside of the office and the instrument is inside the office? If we want to access that instrument, by default, our company's network will block us. Or let's say you're working with a contractor or a CM and you want to be able to access an instrument at their location or a test system at their location. By default, networks will block this. So let me first talk about how to get by the firewall on a personal router. And once again, this is well published on the internet, and so some of these topics I talk about here, such as port forwarding and DMZ, you could do a search on that, and there's plenty of instructions on how to configure a router to do this. But once again, a router is going to block incoming connection requests to anything on its local network by default. Now, to get around this, there's two main ways to do it. You can configure the router to do port forwarding or to do DMZ. And I believe DMZ in the past stood for demilitarized zone. Now with the DMZ, you just tell the router, you say, anybody who tries to connect to you or tries to connect to your network, send that connection request directly to this local IP address. So let's say you have an instrument connected on that router's network. And the instrument's IP address is 1111. You say anytime someone tries to connect to the router, automatically send a connection request to IP address 1111. And so what that will do is protects any other device on that router's local network and just sends all connection requests to that local instrument IP address. Port forwarding is a little more complicated, but the idea is the one disadvantage to DMZ is the fact that you can only use it to connect to one instrument because it's going to forward everything to one IP address. So DMZ works fine if you want to control one instrument that's behind a router. It doesn't work good if you want to control multiple instruments. So that's where port forwarding can come in. Port forwarding allows you to specify an IP address as well as a port. So if we think of, to use an analogy of a home's address, you could say the IP address is like your home address and the port is a door or a window on your home. So by specifying an IP address along with a port, you're telling exactly where you're connecting. Now, ports are used for every type of connection over an Ethernet network. For the internet uses port 80. There's certain standard ports that everybody uses for certain types of application. And then there's a whole list of ports that are sort of open for anybody to use. So to kind of get to the point, with port forwarding, you're telling the router, okay, any type of request that comes in on a certain port, send it to a local IP address with this port. So the idea is you could set up instruments saying any time a connection request comes in for this IP address on port 10,000, send it to this instrument on port 5,000. And once again, you can set up a whole list of these port forwarding rules that allow you to access multiple instruments on the router. Once again, port forwarding can kind of be difficult if you're not too familiar with network terminology, but once again, there's tons of ways to learn about it just by searching on the internet. Okay, the company's network security. So chances are your company has a fairly sophisticated security. IT puts a lot of work into making sure the computers on your network are safe the information on your servers are safe and you're not vulnerable to attack. But once again, that puts a hurdle in your way if you want to contact an instrument that's on your company network and you're at home, or you're at the cafe, or you're at the airport. There's 4 ways, though, that we can sort of get around that. The first is the most obvious, the VPN. So if your company provides a VPN service, a virtual private network service, wherever you are, you can log into your company's network, and all of a sudden your computer appears to be on the company's network, even though it's outside, and that's what the VPN does. Of course, VPN does add overhead and can sometimes be unreliable, but it is an easy way to access, to remotely log into a computer in your office or to access an instrument in the office. Another way is the cellular router. Now, in a lot of people's offices, they're not allowed to connect instruments to their network. The cellular router allows you to do this. Now, we talked about the cellular router earlier, using it as a tool where the instrument is outside of the office and we're inside the office. Of course, we can also use it the reverse way. We could connect our test system or an instrument to the cellular router's network, and we could then access the cellular router from anywhere. And of course, this isn't going to make IT mad because, once again, the instrument or the test system is totally independent from the company's network. Also, another way to do this is using the cloud, and I'm going to talk about this in the next section in more detail. And another way to do it is using a secure access service, and I'll show you what that is on the next slide. So here in the U.S., and I'm not sure how far Lantronix works, but I believe there's other companies besides Lantronix. But the idea is Lantronix offers a service called Access My Device. So what Lantronix will do is, like I mentioned before, an instrument acts like a server, and you can't initiate a conversation with a server on your company's network outside of your company's network because it wants to protect the computers inside its network. What Lantronix does is they make a device for about 150 euros that sits inside your network. They call it a spider, and you connect the spider to your company's network and to the instrument in between the connection to your company's network and the instrument. The spider then acts as a client. So what happens is Lantronix has a server in the cloud, and if you want to connect to an instrument that you have connected to your spider, they will give you an IP address to connect to their server. And what it does is the server appears as the instrument. So you type in your IP address to access your instrument outside of your company's network. This request goes to the Lantronix server. The server is in constant contact with the spider because the spider can send requests outside of your company's network like a client. So the spider is constantly pinging Lantronix's server. So when a connection request comes in, the server is already in communication with the spider, and the spider just passes the data back and forth to the instrument. And it makes you appear as if you're on your company's network accessing the instrument easily. But once again, you can find out more information on Lantronix and their Access My Device service by going to the Lantronix website or just searching on some of the keywords here. Okay. Moving on to the 5th section, the rise of smart devices and the cloud. So first let me talk about smart devices. Smart devices are great because they have ubiquitous access to cellular network and therefore the internet network, meaning I can be at the airport, I could be in the car with someone, and I can access the internet, I can retrieve data, I can communicate with people, so on and so forth. Also, smart devices provide a way to connect to an instrument from anywhere, or to get test data from anywhere. Now, for instance, let's say you're doing a long-term data logging test that takes months or weeks or days, and you want to be able to poke in on that instrument every once in a while or that test system to see its progress. The smart device provides a great way to do that. Now, once again, let me move on to the next slide real quick. Like I said, it has ubiquitous monitoring, controlling of testing, and connect to almost anywhere. It has an easy-to-use user interface. The problem is the challenges with using smart devices today to control instruments is that there's no programming tools, or there's very little programming tools. There's very little I/O drivers. You know, if we want to build a test and measurement program today on a PC, it's pretty easy. I mean, we have you know, programming suites such as MATLAB, LabVIEW, V that have all these built-in drivers for connecting the instruments, for easily controlling them. We don't necessarily have that for smart devices. Now, if you look at the link below, we have actually developed some basic programming tools for Android and the iOS for using these devices to control an instrument or access an instrument. And the idea is to control an instrument or an LXI instrument with these devices, you have to use LAN sockets. And if you're familiar with LAN sockets, they're a very tedious way to program and manage a connection and manage data. What we've done, if you go to agilent.com/find/smart-devices, is we provided some basic tools that abstract the sockets from you to basically give you a Visa-like layer to communicate with an instrument using a smart device. We also provided some plotting tools and stuff like that. Now, one thing I should have stated earlier is one of the challenges to controlling an instrument with a smart device is a smart device is not always connected, meaning you don't know what the network's connection is going to be like when you jump in the car, drive to it, or jump at the airport. So you can't use the smart device as an always connected device controlling a test system. So the way it better works is as a way to monitor a data logging instrument that can sort of run on its own and just kind of jump in on it every once in a while to collect the data or to see where it's at, or to monitor a test system, and a test system that's being controlled by a PC. And once again, you can use a smart device in this way to just simply remotely log into the PC, because there's a lot of applications now or apps out there that allow you to remotely log into a PC. Okay, another way to do it with a smart device is to use an intermediary between the smart device, and that's sort of what I just said with the PC, but that intermediary could also be the cloud. So using the cloud for test. So what are the advantages to using the cloud, or what is the cloud? The cloud basically is, how should I say it, is basically a way to basically provide dynamic storage and dynamic computing power outside of your company's network. And you're totally abstracted from this computing power, from this memory, from this cloud space, as I'll say. The advantage of the cloud, though, is it allows you to basically create a platform that could control multiple instruments sitting outside your company's network, and can also allow you or a CM you're working with or a contractor you're working with to access test data from anywhere at any time. And you might be saying, well, how would I do this? Well, I'm going to show you a quick example. So let's say we have a PC running, controlling an instrument or controlling a whole test system inside our company network. And let's say we have a program that's writing the test data to a file that's stored on the computer or somewhere on our company's server. Now, anybody inside the company's network could access that test data, but people outside the company's network can't. The data is blocked from them with good reason, because we don't want the data to be open on the internet. But what we could do is use a cloud storage service, and instead of having the computer write the data to our server, we have it write to a cloud storage service folder, and that folder will automatically sync the data from the computer to the cloud. And once again, we can do this without violating security protocols because the computer is a client. It is initiating the conversation with the cloud, writing the data to the cloud, and then outside the company's network, whether it be through your home, at the airport, using a smart device, using a computer, we can access that data on that cloud service. And once again, you might be saying, well, is that secure? Yes, it is secure because a lot of cloud services make you log in, provide a password, so on and so forth. And so at this point, you might be saying, well, that sounds like a lot of work for programming. But the idea is cloud services or cloud storage services are already set up, so there's no programming required. And I'll show you what I mean on this next slide. So I basically did this. I set this up. I had a device I was monitoring in an environmental chamber, and I wanted to monitor the device over an 8-day period. Now, I actually had to go on a business trip to Japan during that 8-day period. So what I did as an example is I used V, and I used a 34972, which is a data acquisition unit from Agilent. And in my environmental chamber, I wrote this program. It controlled the instrument, it monitored the instrument, and it grabbed the readings from the instrument and stored them on a folder. Now, what I used for my cloud storage program is I used a service known as Dropbox. And what Dropbox does is it sets up a common folder on your PC. And so what I did is I had my program write my test data to that folder in an Excel file. Now, Dropbox, the Dropbox folder on your PC will automatically sync that data to the cloud. And so any other computer or smart device, such as a tablet, as long as I have my Dropbox account set up on those controllers or computers, Dropbox will automatically sync the test data to them whenever they connect to the internet. So you can actually see a screenshot from my Excel spreadsheet. It was taking temperature measurements as well as fan speed, voltage measurements, and syncing them to the cloud. I could then, at the airport, using my iPad or using my laptop computer at my hotel in Japan, I could then see the data and monitor the data. And then finally, I could even take it one step further, and I'm going to place an arrow here, is I actually created 2 cells on the Excel spreadsheet that allowed me to control the fan and the heater in the environmental chamber. So what happened is if I go into my Dropbox folder on my computer that's in my hotel room in Japan, I could change one of those from on to off or off to on. The next time the program reads the Dropbox file, it would read those boxes, see if I changed one, and then send a trigger from the instrument to turn on the heater or the fan or anything like that. So here's a way securely that I set up a way for me to access test data outside of my company network on a test system that's running inside my company's network using the cloud. And once again, I didn't have to do any special programming than what I would have normally done. Now, you can always go much farther than what I did. You could develop a system where you make a scripting language to actually reconfigure tests. So, you might have a README file in your Dropbox account. You can actually put test routines in there. The test system reads that file every once in a while, and that file could tell the test system to start. It could tell it to run certain protocols, and so on and so forth. And then once again, it could store the data to the cloud. And if you have a global design team or manufacturing team, anybody can access that test data. Anybody can access that test system as long as they have the right permissions and the right password to get into the Dropbox or any type of cloud storage service. So once again, that was a sort of a long description. For more information, you can find out by following that link at the bottom of the slide, and we'll also have that link at the end of the presentation. So just to conclude, we talked about a lot of things in this presentation. We talked about how to go wireless by controlling your instruments. You know, the simplest way is the wireless router. We can go even further by using pocket routers and configure some as wireless bridges, configure another as the router, and we can essentially turn all of our instruments on our benchtop wireless. Also, we talked about using RF bridges, cellular routers, and Wi-Fi repeaters for doing long-distance wireless access of our instruments. We talked about some of the security hurdles we can run into with routers and our company's network, and we talked about port forwarding and DMZ. Once again, port forwarding can be a little tricky to understand if you're new to network, but once again, there's plenty of information on the internet about setting up a router and port forwarding. We talked about the cloud, and we talked about using smart devices for instrument control. So at this point, I'm going to turn it over to Marlo, and you can see on this slide there's a lot of the links to some more information on some of the stuff we talked about here in this presentation.
All right, thank you very much, Neil. Now it's time for the question and answer portion. You can send questions in writing now through the Q&A functionality of the WebEx meeting. We'll also do our best to answer your questions during the session, but may come back to you after the session if we haven't been able to. And please be reminded that while the answer to your question may be published for others to see, we will keep your identity private. So with that being said, we do have some questions in the Q&A. So Neil, what type of I/O latencies do you encounter using cellular router and RF Ethernet bridge?
Okay, great question. Yes, I don't think I mentioned much on cellular router. I did mention briefly on the RF Ethernet bridge. When I did my testing, I experienced at least a second of delay, and that was with a clear line of sight with a device that was a couple kilometers away from me. Now, at certain times of the day, I experienced anywhere from 2 to 5 seconds of latency. So with an RF Ethernet bridge, you know, it's not going to give you exact trigger timing. It's more of a, it's not going to give you a very repeatable latency either. So once again, any type of software that's going to be used to control or monitor an instrument across an RF Ethernet bridge would have to be robust as far as a long network timeout time, and have to be able to handle if a connection was lost, reestablishing that connection. Now for routers, it can be highly dependent on the network coverage in your area, the current traffic in that area, and so on and so forth. So, and also the distance between the instrument and the device. So for kilometers or multiple kilometers, or even across, you know, here in the U.S. state lines, I typically only encountered about a couple seconds of latency. And if you repeated the test or the communication with the instrument, that latency stayed for the most part the same. You just have to be aware, though, in certain areas. For instance, if you have a cellular router set up near when a football game's going on and there's a huge crowd, your latency is going to definitely jump up. But it can be as low as just a couple of seconds for thousands of kilometers of space between you and the instrument.
Great, thanks, Neil. We do have another question. Can you elaborate on how port forwarding works and how it allows you to access multiple instruments behind a router?
Sure. So I did talk about port forwarding a little bit. Once again, it can be tricky if you're not familiar with networks, but once again, the idea is the IP address of the router And when you contact an instrument behind a router, you're actually using the router's IP address, and the instrument has a local IP address that was assigned by the router. So once again, the IP address is going to get me to the router, just like the analogy I used, the address, your address or my address is going to get you to my home. The port is going to tell you where to get in the home, whether it's through the window or through the back door or whatever. And there's thousands of ports. Now, if I have 3 instruments that I want to access that are behind the router, I may use I'll use 3 different ports to contact those instruments. So one might be port 1, one might be port 2, one might be port 3. Then I'll tell the router, whenever you get a connection request on port 1, you send it to this local IP address on whatever port. For the port 2, you send it to this local IP address, and for port 3, you send it to this local IP address. That allows the router, once again, you're using the same IP address for each communication, you're just using different ports. And that allows the router to know what instrument you're communicating with at that time. And once again, there's plenty of information on port forwarding on the internet if you do a search on it.
Okay, great. We do have one more question. Can you comment further on security for storing test data in the cloud versus storing data on a company network?
Okay, yes, great question. So I did mention how we can use a cloud service or a cloud storage service to basically put our test data and even to allow certain levels of control of a test system or an instrument. Now, a cloud service, once again, is run by a separate company, but once again, they specialize in internet security or network security because that is their business. So you typically set up a password, a secure password. Whoever has that password can then access that cloud storage account. Now, you can also assign read or write privileges to certain users. So, for instance, you may say, this test data file cannot be written to or deleted. It can only be read by these certain users. So maybe that would be a CM or a contractor that you're working with. Your information, let's compare the cloud to storing the information on your local network or inside your company. Now, storing the information inside your company seems fairly secure. The problem is, though, is a would-be attacker that's interested in that test data knows where it is. So if I'm trying to steal company test data or company secrets from company ABC, I know that if I can somehow get into company ABC's network, I can maybe find that test data. But compared to storing it in the cloud, a would-be attacker doesn't know that you're storing test data in the cloud. And also, they would have no idea where to look for it. So in some ways, a cloud can be even thought of as more secure than the company's network simply because they have no idea what your username of the account is, and they have no idea what the password is. Maybe they have no idea what cloud service you're using. So therefore, they have no idea where to look for the data, whereas storing it on your company's network, a would-be attacker would know where to look for the data. You're just dependent on your coworkers and your business partners keeping the secret as far as what cloud storage service you're using and the password.
Okay, great. Those are all the questions I see in the Q&A box. I'll turn it over to Shri now.
Great. Thank you so much, Neil and Marlo. Thank you for presenting. And thank you for everybody for attending. If you have any questions after the event or want to ask these questions offline, don't hesitate to contact us on the address provided. In a few seconds' time, when I close the event session, an evaluation form will pop up on your screen. We do appreciate your feedback. Again, thank you again for your attendance. I wish you all a nice continuation of your day. I hope to see you again probably in the next time we have another web seminar. Thank you. Have a good week. Bye.